Hey guys, so you made it into group 3 because it looked like you knew when to use a Roman numeral, but you were not using them correctly, and you weren't putting the right Roman numeral on the answers for the quiz. So I wanted to go over with you guys today how to use the Roman numeral correctly. How do you figure out the Roman numeral the right way? So the first question we need to answer is, why do we need a Roman numeral? Okay. And if you look at your periodic table, we're going to talk about that for just a minute. We labeled on our periodic table the elements that have only one possible charge. And we did it in permanent marker because those charges are permanent. So group 1 is always going to be +1. Group 2 is always going to be +2. Silver is always going to be 1+. Zinc and cadmium always 2+. Aluminum 3+. So with those, it doesn't have to be said. Every other scientist knows aluminum's always 3+, so you don't have to say it. The problem therein lies when you're talking about one of these other metals: copper, titanium, bismuth, lead, tin, gallium. These other elements here, they could be more than one thing. So when I'm talking about one of them, I have to specify which one I'm talking about because they're going to have extremely different chemical bonds. They're going to have different chemical and physical properties. And so I have to be clear about what we're talking about. So we use Roman numerals to tell the charge of a, remember our vocabulary? Multivalent, so more than one charge. A multivalent metal. Because we have to say what the charge is. Or else, how do you know? You aren't going to know. Unless I tell you it's copper 1, you're not going to know. Am I talking about copper with a 1+ charge or copper with a 2+ charge? It could be either one. So we have to say it. Okay, so the charge has nothing to do with how many atoms there are. It has nothing to do with any of that. It's literally just the charge of the metal. So let's talk about how that affects what we're doing. Okay, so let's say I give you 10, oops, Miss Crane, you're so funny. All right, so I give you 10 2 sulfide. This 2 right here, this Roman numeral 2, is the charge of the tin. Okay? And if you look at your periodic table, sulfur over here, 2- charge. Okay? So we've got tin, which, ladies and gentlemen, please look at your periodic table. Do not make a guess at what the symbol is. I can't tell you how many people put palladium for lead yesterday. Please do not do that. If you don't know what the symbol is, you're not certain 100%, 1,000 times correct. Please look at your periodic table. I took a lot of points off yesterday because people were too lazy to look at their periodic table. Tin, for the record, is SN. Comes from the Latin name. I know it's weird, but it is what it is. So we have SN and we have S. The 2 from the tin goes to the sulfur. The 2 from the sulfide goes to the tin. Now the big ticket item here, one thing that I saw a lot of people do, is they left it just like that. You can't do that, okay? Ionic compounds must be reduced. And what I mean by that is 2 will go into 2, right? 2 divided by 2 is 1. So I can divide both of these by 2 to simplify. Okay, so 2 divided by 2 is 1, so tin gets a 1. 2 divided by 2 is 1, so S gets a 1. So the real formula for tin 2-sulfide would be SNS. Okay, so make sure that you're using the Roman numeral as the charge of the multivalent metal. You crisscross them and reduce. You got to reduce. Okay, so let's talk about going the other direction. Let's say I give you something like PB Okay, and I've asked you to write the name for this. Okay, well, remember that when we initially write the formula, if I give you the name, I have you write the charges, and then we crisscross them and reduce. So we're going to undo that. All right, we're going to uncross the crisscross. So we're going to imagine, because remember we don't write ones, but we're going to imagine that lead has a 1 and oxygen has a 1. So if I uncross that, I take this 1 from here, and that gives lead a 1 plus charge. I take this 1 from here, that gives oxygen a 1 minus charge. Now, the one thing I saw a lot of people not do, some people got this far, but you can't leave it like this, okay? Because remember, we did label our periodic table very specifically with some permanent charges. Permanent marker, permanent charge. Look at oxygen. Oxygen has a 2 minus charge. Always. That's permanent. Oxygen can never be anything other than 2 minus. Look at this. We have oxygen as 1 minus. We can't leave it like that. Oxygen can't be 1 minus. So let's write our steps here real quick. Step number 1 was to uncross the subscripts. Step 2 is to check the charge of the nonmetal. Okay? It should match. If it doesn't match, this is what we have to do. We're going to multiply all the charges to make it right. Oxygen is supposed to be minus 2, so how would I make a 1 minus, a 2 minus? Well, I'd have to multiply it by 2. If I do that, that gives lead a 2 plus charge and oxygen a 2 minus charge. Now it matches with what's on the periodic table. So step 3 is to multiply the charges to match the nonmetal charge to the periodic table. Okay, so this right here is lead with a 2 plus charge, not lead with a 1 plus charge. So when we write this, this is going to be lead 2 oxide. Okay, a couple of little things that I saw a few people do that I feel need to be said. First of all, Roman numerals only go in the name. Okay? You are never going to write a formula CU Roman numeral 2S. That's a heck no. Nope, 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 nope. Don't do that. Roman numerals don't go in the formula. They only go in the name. And when they're in the name, they are only on the metal. Okay? I saw some people doing this number. They were like, copper 2, oxide 2. Okay, you don't ever put a Roman numeral on the nonmetal because, looky, the nonmetals all have permanent charges. We don't need to say what their charge is because we already know. Okay, so make sure you're not putting Roman numerals in the formula. The only thing that goes in the formula are those little subscripts, and they're real numbers like 2s and 3s. Okay, so don't put it in the formula, and don't put it on a nonmetal. It only goes on the metal because the metal is the only thing that needs a charge specified. All right, folks, so you're going to complete the problem set that I gave you on the paper, on the blue piece of paper that you picked up today, and then you can go ahead and work on the covalent compounds worksheet for tonight. Thanks for watching.